Welcome to CEC lectures. Myself Dr. Preeti Jagwani from Department of Computer Science, Aryabhat College, University of Delhi. In our present series of operating system concepts, we are going through. Presently, we are considering the presently we are learning the topic of process synchronization, and within this topic, today's agenda is bounded buffer problem. So, till this point in process synchronization, which we have taken up after the topic of threads, we have seen firstly we have explored what actually synchronization problem is, where it is required, and then what all could be the possible scenarios, like critical section problem could be there, and we have also considered various possible solutions. And today we are going to explore about one of the very important classical problem of synchronization, that is bounded buffer problem. So, coming to the classical problems of synchronization, what do we mean by this term, the classical problems of synchronization? These are actually a list of problems which are used for testing the proposed solutions or proposed synchronization scheme. So, whenever there is a new solution to the problem of this process synchronization, or whenever there is a new proposed synchronization scheme, we need some standard classical problems in order to test the efficiency of those solutions. So, one of the these problems are known as classical problems of synchronization, and as we go along with these problems of synchronization, we will see that in the proposed algorithms, which we will be exploring soon, semaphores are used, but in practical implementation we can use mutex, locks, and all these things can be used. So, the algorithmic solution is proposed with the help of semaphores. So, within this classical problem of synchronization, we actually have three problems. One is bounded buffer problem, another one is known as readers writers problem, and the third one is dining philosopher problem. So, today what we are going to explore in detail is bounded buffer problem. This bounded buffer problem is also known as producer consumer problem, and it is a common example, it is a common paradigm for cooperating processes. So, when we say cooperating processes, that means here we want to elaborate that there are two processes, one is the producer and another one is the consumer process. So, whenever a producer process works, it basically produces information that is to be consumed by a consumer process. So, for example, we can take the analogy of a client server. So, server here is a producer and client is a consumer. So, whatever server is producing, client is going to consume that particular data or that particular thing, we can say. Or even one more a better example of this producer consumer problem or producer consumer paradigm is the compiler and the assembler. A compiler is going to produce an assembly code, so it works as a producer, and this assembly code is consumed by an assembler. So, this is going to work as a consumer here. So, any client server paradigm or any compiler assembler pairing up is the example of a producer consumer problem. Now, this is the scenario of a producer consumer problem. What do we mean by bounded buffer here? That we will be exploring in a while. So, basically these processes, one is producer and another one is consumer, these are cooperating processes, and these cooperating processes must interact with each other in order to give a complete we can say a complete application. So, these producer consumers basically need to use shared memory. This producer consumer problem, one idea is that they are using shared memory, and when they are using shared memory, the producer is allowed to produce and the consumer is allowed to consume, and that too concurrently. That means these producer and consumer processes must have an available buffer of items this buffer is going to be filled by the producer because producer is producing, and this will be emptied by the consumer because consumer is consuming. And where is this buffer? This buffer is going to be actually reside inside that shared memory which we were talking about just now. So the solution of implementation of this producer consumer, or the idea of implementation of this producer consumer problem, is to use a shared memory. So within that shared memory there is going to be an buffer, and that buffer is going to be kind of, we can say, filled by the producer by the data which is being produced by the producer, and it is going to be emptied by the consumer. That means the consumer is going to consume the data which is available inside that buffer, and that buffer is we can say it's an area of a shared memory. So a producer is producing one item while the consumer is consuming another item. Now why do we need, why this is included inside the classical problem of synchronization? Because of the simple reason that these producer and consumers must be synchronized, so that this should not be the scenario that consumer is trying to consume an item which has not been produced yet. So if the item has not been produced yet, or if the data has not been produced yet, consumer should not try to consume this. So there is an synchronization which is required, that the first thing which is to be done is the production, and the next thing onto that production which is to be done is the consumption. So production and then consumption. So this kind of synchronization is required, and that's why this problem comes under the category of classical problems of synchronization. Now producer consumer problem within the classical problems of synchronization is fine, one thing. But when we are saying that this is also known as a bounded buffer problem, what do we mean by this bounded buffer here is, let's try to understand. So the bounded buffer is actually is the term which is actually related to the size of that buffer which is being shared by both of the processes. So this buffer or this buffer size could be in two variations. One is an unbounded buffer, another one is an bounded buffer. So unbounded buffer is something, as the name indicates, it places no practical limits on the size of the buffer. It can kind of extend it to the extent which is required. But even if it is unbounded buffer, the consumer may have to wait for the new items, but the producer can always produce new items. So for producer, it is not the lack of the space or lack of the memory, lack of the buffer, that where these items will be stored. A producer can always keep on producing new items because the buffer is unbounded, without having to worry about what consumer has consumed and what is not being consumed. But if producer is, we can say, is not able to produce a lot of items or a lot of data, the consumer may have to wait for the new item. So the consumer may may have a problem of empty buffer, but the producer will never face the problem of full buffer, because here what we are talking about is unbounded buffer. Now with this unbounded buffer, if we come to the next variation, which is the bounded buffer. So bounded buffer, as the name indicates, it is a fixed buffer size. So here the consumer has to wait for the items to be produced so that it can consume, and the producer must also wait if there is no space to we can say store the item. So basically consumer must wait if the buffer is empty, that means no item has been produced, so nothing can be consumed, so consumer has to wait, and the producer must wait if the buffer is full. So even if producer is producing something, it cannot be stored inside the buffer if it is full. So in the problem of unbounded buffer, a producer need not to wait, but a consumer may have to wait. In unbounded buffer, the scenario is that the producer as well as the consumer, both may need to wait. And when we try to say, or when we are saying this bounded buffer, or this is kind of an kind of shared memory space, as I have told you, this shared buffer is implemented as a circular array with two logical pointers, one is in and another one is out. This can be kind of, we can say, taken the this can be understood with the help of the circular queue data structure, which is implemented with the help of arrays. So when we implement circular queue, we have two pointers there, one is rear, another one is the front. These are two logical pointers. Actually, these are the indexes of the array. Similarly, when we talk about this shared buffer, or when we talk about this bounded buffer, this is implemented as a circular array with two logical pointers in and out. Now, what is the significance of these two pointers in and out is the variable in, or the pointer in, is pointing towards the next free position in the buffer. That means the where the data has to be taken in and stored. So, that is what the in pointer pointing to, and the out pointer in is pointing towards the first full position in the buffer. That is the pointer from where the item is going to be taken out. So, in is pointing towards the position in the array where the item is to be stored after production, the new item is to be stored in, and out is pointing towards the location from where the item will be taken out or item will be consumed. So, this is going to be implemented with the help of two logical pointers, one is in, another one is out. So, till this point, let us recall what we have seen. So, we have seen what is actually classical problem of synchronization, what all three problems will be there, and today we are going to study the process of bounded buffer problem or producer consumer problem. We have seen what is producer consumer, we have seen the examples like compiler and assembler, and we have also seen the example of server and client. And apart from that, we have seen what is bounded buffer, what is unbounded buffer, what all can be the problems, or what all can be the constraint in case of unbounded buffer, and what all can be the constraints in case of unbounded buffer. Now, coming to this bounded buffer problem, we have seen that there is a shared buffer which is going to be implemented as a circular array with the help of two logical pointers. One is for keeping the data in, another one is for taking the data out. And when we say that this buffer can be in two stages, one is the buffer can be empty, and the buffer could be kind of, we can say, full. So, buffer is empty when my in pointer or the index of the index in the array is going to be equals to out. So, when value of in equals to out, then the buffer is said to be empty. Well, while we are talking about the buffer is full, that means when this in plus 1 mod buffer size equals to out. So, that is the situation where the buffer is full. So, buffer is empty when in equals to out, that means nothing is there, and buffer is full whenever this in plus 1 mod buffer size equals to out. So, you can correlate this condition of in plus 1 mod buffer size equals to out with the overflow condition of your circular queue of the data structures. And then when we talk about bounded buffer problem in more detail, that is, the bounded buffer problem is something which is going to elaborate, or which is going to illustrate the inter-process communication using a shared memory. So, there is a shared memory, and there is a kind of inter-process communication which is happening between the two processes. One is the producer process and another one is the consumer process. Now, what all kind of variables, what all data will be required in the implementation of this inter-process communication? One is, as we have seen, there has to be some buffer size, because we are talking about the bounded buffer problem. So that buffer size has to be there. Then we have the array which is kind of we can say buffer, which is equivalent to that buffer size. So for example, we have buffer size as 10, so we need to have an area which is of 10 items, and we need to have two logical pointers in and out. So initially we have given in and out both, or we have initialized in and out both as 0, and whenever kind of producer start producing, in will start incrementing, and whenever your consumer starts consumption, then the out is going to be, or the value of the out is going to be affected. Apart from that, we may need also one structure which is related to what kind of information we need to store here, what item we can be storing here. Then we have the producer process which is having a local variable in the name of next produced, and in which the new item is to be produced. So whenever this next produced variable is filled, that next produced variable has to be taken to the in pointer or in index of the array. Similarly, we have the consumer process, which is with a one local variable which is next consumed, in which the item to be consumed is to be stored. So the item to be consumed will be stored here, and the value of the out index or value of the out pointer is going to be kind of updated, we can say. So here we have one local variable with the producer process named as next produced, in which the new items to be produced is stored, and the consumer process is also having a local variable in the name of next consumed, in which the item to be consumed is to be stored. And then what kind of programming or what kind of code we are going to write for this producer consumer problems, let's see. So once we have one item or any variable of type item, and the variable has named as next produce, and while your producer is producing an item and the buffer is full, then you need not to do anything. So buffer is full, that condition is checked as while in plus 1 mod buffer size equals to outs. That's the condition of that buffer is full, and that we have already seen what is the condition for buffer full and what is the condition of buffer empty. So in plus 1 mod buffer size equals to out, that means buffer is full, and while the buffer is full, it has to do nothing. This is we can say indicated with the help of the semicolon after the while statement. So this while statement and keep on running doing nothing till your buffer is full. Now whenever this condition becomes false, that means the buffer is not full. Now it is having at least the size, at least the space of one element of the type item to be kind of stored here. Till this point, this is going to go nothing. As soon as the space is available, then this next produced is going to be stored inside the buffer array, at the position of the pointer in. So where this in is going to take us to the position where the next produced item is to be stored, and then we need to increment the size of in. And while this is kind of we can say it is implemented in the form of a circular array. So instead of having just saying in is equals to in plus 1, we will be saying in is equals to in plus 1 mod buffer size, and this will be the structure of the producer process. So here I am repeating it once again. What is given on the screen is, first is the item next produced. Item next produced is the item which will be that is the variable in which the item produced will be stored. And while this process is going on, we need to keep on continuously checking that whether the buffer size is whether the buffer is free or not, or whether it is in the situation of overflow. So, if the buffer is completely filled, that means in plus 1 mod buffer size equals to out. This is the condition of buffer full. So, when the buffer is full, while loop will keep on running without doing anything, and the moment as soon as at least one place in the buffer array is blank or is kind of emptied, we can say we will take the item which is next produced, or we will take the variable which is next produced, and whatever is stored inside this variable will be given in the buffer at the position in, and then we have incremented the in with along with the rules of the circular array or circular queue, we can say. This was the structure of the producer process if when the memory is shared. Now apart from this, we also need to see what is the structure of the consumer process when the memory is being shared. So, as I have already told you that the process the consumer process is having one variable which is named as next consumed, and this next consumed is going to store whatever is going to be taken out from that buffer. But before starting before taking something out from the buffer, we also need to check for the underflow condition. That is something when your buffer is empty and consumer is not having anything to consume. So, we need to check the status of buffer empty, which is going to be checked by the condition in equals to out. So, while in equals to out, that means the buffer is empty, consumer is not having anything to consume, it is not going to do anything. The moment as soon as it is going to have something to consume, that means producer had produced something and kept inside the in location. Now we need to take something out from the buffer, and that buffer out is going to be kind of stored inside the variable next consume. So, next consume is the variable which is to be taken out, and then we have incremented out is equals to out plus 1 buffer size. This is in accordance with the increment rule of a circular array. So, that means it is going to consume the next item whenever it is available. If it is available now, the fine, otherwise it will wait while in equals to out. So, this is going to happen. So, if we try to understand once more the structure of producer and the consumer processes. So, producer is having an item which is next produced, but it will wait till the buffer is completely filled. Whenever it is going to have any space, it will store the value of this next produce onto the location in, and will increment the value of in according to the rules of circular array. Similarly, when we talk about the consumer problem, this consumer problem is going to be in the we can say a waiting state if the consumer is not having anything to consume, that is the buffer is empty. So, till the buffer is empty, nothing to be consumed, it will wait, and as soon as it is going to have something to consume, then it is going to take that position or take that data item from the buffer. It is going to put into the variable which is next consumed, and it will increment the value of the out pointer as it should be done for a circular array. Now, this scheme is allowing at most buffer size minus 1 items in the buffer at the same time, and also with these two codes, what one situation which is kind of not addressed is when both the producer process and the consumer process attempt to access the shared buffer concurrently. If they are not accessing it concurrently, that is okay. So, producer is producing, consumer is waiting, and then consumer is consuming, producer will waiting, that is fine. But if at the same time producer and consumer are going to access that shared buffer concurrently, this is this is a situation when there will be we can say inconsistency in terms of the whatever the data items are stored inside the buffer. Also, this scheme is allowing at most buffer size minus 1 items in the buffer at the same time. So, here are the problems with this scheme with the code which we have seen in the producer and the consumer problem till this point. So, with this situation we have what we have taken up till this point is what actually bounded buffer problem is, why these classical problems of synchronization are necessary. Then we have seen bounded buffer and unbounded buffer, and we have elaborated the problem of this bounded buffer, what all processes will involve into it, what will be the structure of those processes, what will be the code under those processes. And then we have also seen that what is the problem within that structure which we have just explored. And here is the list of references which is being used for the preparation of this material. Hope you have enjoyed the lecture. Thank you for the patient hearing.